video we are going to be sketching quadratics by completing the square. Now in order to do this you might want to watch my video on how to complete the square first, just to get an idea of how this is going to work. So I'm going to just run straight into an example. So we've been asked to sketch these graphs by completing the square, giving the x-intercepts in exact form. That means we don't want any decimal answers, and that means we may need to leave our answers in what we call third formation, which basically means leave it with the square root. Now, the first example is y equals x squared plus 6x plus 15, and the second example, as you can see, is y equals x squared minus 3x minus 1. Let's do the first example first. So we've been asked to complete the square. Now, I just want to give you a reminder that turning point form, which is y equals a bracket x minus h all squared plus k, this is basically used when we complete the square. So if we can write it in turning point form, we can give the turning point, which a reminder is hk. So what I'm going to do is I'm going to complete the square and get this one looking in this form, and I'll easily be able to give the turning point. So let's complete the square first. So let's do example 1. So the first thing I'm going to do, remember, to complete the square, I need to add the half the coefficient of the x to both sides. Okay, so let's move this one over first of all, before I can do that. And obviously I'm going to show my working down the right hand side, so I'm going to add 3 squared to both sides to make the perfect square on the right hand side in this particular case. Okay, so I'll be adding 9 to both sides, so I've got minus 15 plus the 9 on the right, and on the left I've got, sorry, on the left and on the right, I'm getting my left and right mixed up, I'll have x squared plus 6x plus 9. That on the right means that I can factorise that perfectly to give me x plus 3 all squared, and on the left I can work that out, and that gives me minus 6. Okay, so I can now move that over, and that gives me 0 equals x plus 3 all squared plus the 6. Now what we've got is we've now written this in turning point form, so we've completed the square and it's now in this form here. So when I want to sketch this graph, I can now put my heading. So I've got the turning point, which of course is our hk, and then I can find the x-intercepts and the y-intercept. Okay, so the value of h in this case is minus 3, and the value of k in this case is 6, so my turning point is minus 3, 6. Now let's move over to the x-intercepts. Now this one's a bit trickier because I'll need to go back to this line up here, because obviously it's just the same as moving this 6 over, because I've placed it equal to 0, so I'm going up to this line here. So I'm just going to write minus 6 equals x plus 3 all squared. And what I'm going to do is try and solve this. Now to solve this, of course, I'm going to square root both sides. What happens when I square root a negative number? We can't do it. What does this mean in terms of our graph? Well, there's no solution. So that basically means there are no x-intercepts. So in fact, the graph is above the x-axis. And we can see that just by looking at the turning point. Look at the turning point, it's sitting at minus 3, 6. 6 is that y coordinate, so it's way above the x-axis. So as we can't solve this, there are no solutions to our x-intercepts. The y-intercept, well, we just substitute x equals 0 into our equation. Now if I sub x equals 0 into this original equation of y equals, I get 15. So the y-intercept is 15. Now it's easy to sketch because I have some important points. I need to know it's a positive parabola, so it's going to be a smiley face, and I'll just sketch that and show you what that looks like. Alright, so there we go. Let's do the second example now. Alright, so as I'm going to be solving this later on, I can place it equal to 0, and that means I can move that minus 1 over to the other side, which I'll do now. So I'm going to move that minus 1 over, so I'm going to show my working. I'm adding 1 to each side, so I've got 1 equals the x squared plus, minus 3x. Now, what I'm going to do on the right-hand side is I'm going to make that a perfect square. So I need to add half the coefficient of the b squared. So I'll be adding 3 upon 2 squared to both sides, which is 9 over 4 to both sides. So if I do that, I get 1 plus 9 over 4. Obviously, you need to work on your adding fractions. So adding that 4 over 4 plus 9 over 4 gives me 13 over 4. And obviously on the right hand side I've now got that perfect square. So remember that's x minus 3 upon 2 all squared equals the 13 over 4. Alright, so obviously I'm going to use that to solve to go on and find the x-intercepts, but I'll do that later. Let's just write it in fully completed square form where we can identify the turning point. Alright, so now it's in turning point form. I can write down that the value of hk. H is 3 upon 2 and k is minus 13 over 4. So let's write that down. So our turning point is at 3 upon 2 comma minus 13 over 4. Now let's go on and find those x-intercepts. Now remember I said I was going to use this line here, and of course I'm at the point now where I need to solve for x. I'm expecting 2 solutions and I want to write them in exact form. So I'm going to square root both sides. Now when I square root both sides I get positive and a negative. So obviously I square root the whole thing. I get root 13 over root 4, which is root 13 over 2. And plus or minus, don't forget. And I'm left with x minus 3. So now I'm going to use solutions. So I'm going to say, right, okay, let's move the 3 upon 2 over and look at the both case scenarios. So the first solution is either x equals root 13 upon 2, positive root 13 upon 2 plus the 3 over 2. This pen's struggling a little bit. Okay, so I've written it now. Okay, look at this. The denominator for both fractions is 2, so I can put that together to make it look neater, like so. And then the second solution is obviously the negative version of root 13 over 2 plus 3 over 2. And I can write that neater as either 3 minus root 13 over 2. Okay, let's look at that y-intercept. So let's go back to the original equation. We can see here if we substitute x equals 0 into this, we get y equals negative 1. So that's an easy one to do. Now I'll just show you how I'm going to put those points on this sketch and show you what the graph looks like. And that concludes my video.